In this video, I will be discussing with helium neon laser construction and working. Now, this laser was first built by scientist Khalid Jawan in the year 1959 at Bell Laboratory. Now, this is the one of the laser cavity. Now, it consists of narrow long discharge tube. It is made up of quartz whose length is 1 meter and whose diameter is 1.5 centimeter. The tube is filled with a mixture of helium neon gas in the ratio of 10:1 at very low pressure, that is 1 tar. The tube has two electrodes, that is cathode and anodes. Cathode means filament, which is connected high DC power supply, which is in the order of 1000 volt. When switch on the power supply, the filament, that means cathode filament, gets heated and emits the electrons. These electrons moving start towards the anode side. During the times there will be some collision takes place. These collisions we will discuss later. The tube has sealed with a Brewster window, which is nothing but one of the plate, which will be minimize the optical noise, which is nothing but scattering, reflections, refractions. After the two reflecting mirror have been fixed here, one is fully reflecting mirror connected in this position, is the partially reflecting mirror. When the photon, it will be oscillation takes place from moving from left to right, right to left. Once the photon gets high intensity, then only the laser light beam will be output. Now we'll take the working. Now this is the energy level diagram of both helium and neon. F1 is the ground state of helium atom. F2 and F3 are the short-lived and metastable states. Similarly, in the neon atom, E1 is the ground state, E2, E3, E4, E5, E6 are the excited state. Here, now this is pumping as made done through the electrical discharge. The applied voltage is 1000 volts. Here, there will be the electrons. It is moving. Already I told you in the previous diagrams. The electrons moving from cathode to anode. During that times, there will be a collision takes place. Such a collision we can call as inelastic collisions, because in these collisions, before collisions, after collisions, there will be some energy difference. Here, the E1 is the electron of before collisions. He represents the helium atom in the ground state. This is the before collisions. After collisions, electrons after collisions, E2, He star is the excited helium atoms. Here, there will be a collision takes place where the electrons, it will be transfers its energy to the helium atoms. Helium atoms, there will be a transition takes place from ground state to the excited states after absorbing energy from the electrons. It moving towards starts F2 or F3. Then there will be a helium atom go to excited state. Afterwards, there will be some energy diffs as same. That means here in the neon atoms, E4 and E6, whose energy is same as the in the F2, F3 in case of helium atom, whose energy is same. There will be a collision takes place. That collision means here excited helium atoms and ground state neon atoms, there will be a collision takes place. These collisions we can represent it in the equation is this. He star is represents the helium atom in the excited state. Ne represents the neon atom in the ground state. This is the before collisions. After collisions, the helium atoms, its energy transferred to the neon atoms, it will be come back to the ground states. Then neon atom come to the active now. Afterwards, neon atom goes to excited state, that is E4 and E6. Then it will be a downward transition takes place, E6 and E6 to E3 and E4 to E3. Here now E5 and E3 and E2, afterwards the neon atoms, there will be a come to E2, then neon atoms collide with the walls of the tubes, then it will be come back to the ground state. This is the process. Here, there will be achieving a population inversions. That is the one of the condition in the case of the laser. Here, when the neon atoms comes to E5 and E6, then afterwards comes to E2, there will be the probably the depopulation takes place. This depopulated population, which is helps to maintaining the population inversion in this E6 and E4 to E5 and E3 respectively. Then afterwards there will be possible three transitions, that is E6 to E5 transitions, which is in the order of 3.39 micrometer, which comes under IR regions. That is this is in terms of nanometer. From next transitions E6 to E3, this is comes under whose wavelength is 632.8 nanometer, which is comes under the visible, that means red light. The next transition E4 to E3, whose wavelength is almost 1152.3 nanometer. This is in terms of micrometer we can represent here. This is also comes under the IR regions. Out of this, the second one, that is E6 to E3, which gives the continuous output compared to others. Now using these laser, they have to use for different applications. Now we'll come to the applications. There are huge applications in the laser have many important applications. They are used in common consumer device such as optical disk drive, laser printer, barcode scanner. Laser are used both fiber optics and free space optical communications. They are used in medical field, that is surgery, various kind of skin treatment, industry, cutting, welding, drilling. Almost they are used for military purpose also. We will discuss one by one. The first one, I used to take the laser industry. In the industry, now we'll come to the first one. These are all the different diagram here. This is the laser welding. In this welding, the basic principle is that beam high energy can be focused on the small area where welding joint has been made. The material melts spot due to heat generation, but after cooling, very strong joint is obtained. Here, there are some advantages in the laser welding. This is as compared to the other welding, the strong joint it will be obtained. There is no destruction shapes in this here. In the welding spot we can easily identify it. Here there is no foreign material has been used or impurity cannot be used here. Now this is very helpful for the microelectronic device because where these components are very heat sensitive materials. That's why this laser welding can be helps to that components. Now come to the laser drilling. In this laser drilling, it having used for the small holes whose in the order of 0.2 millimeter to 0.5 millimeter. Such a types of drilling, it is not possible in the ordinary drilling. We can use the laser light. That means almost they have used for the industry purpose. Carbon dioxide laser, CO2 laser, they have to use it here. Here, there is a very finite hole can be made. There is no problem for mechanical stress. We can do the as far as possible. Can avoid the mechanical stress. Now these are some advantages of as compared to the ordinary drilling. Now come to the welding. In the case of laser cutting, here they have to use for the gas jet here. For different gas jet we can use it here. Now oxygen we can pass over here along with the laser beam. The combustion of gas burn in the metal. There is a tiny part splinter along the molten part of the material blown away by oxygen jet. The blowing action increases, the depth and speed cutting also increases. Now it having some advantages as compared to the ordinary cutting. That is high production rate as cutting process can be programmed. The quality of cutting is very high. No chemical change or thermal damage to the material is being avoided. The mechanical stress is not induced. These are the different applications in the case of the industry. Now come to the medical. In the medical, the use laser medical field has been increased tremendously due to its ability and interact with the biological molecules. The major area of medical applications include ophthalmology, microsurgery, dermatology, and cancer photochemotherapy. The best use of laser in medical field has been ophthalmology for repair of retina detachment. Mostly the ruby, argon, and Nd:YAG laser are used for this purpose. Now we'll take the laser communications. The laser communication technology is continuously undergoing development to higher transmitter frequency, starting from few hundred kilohertz to several hundred terahertz due to employment of laser in various complex fiber communication systems. Already we discussed in the first itself, printers, CD drive, in the purpose of laser can be used here, and also the optical fiber communications extensively used for the long distance optical data transmissions. They have to use for the transmitter source of light, they can use it because the laser is a monochromatic one. Now free space optical communications for inter-satellite communications is based on the high power laser generating collimated laser beam which program it over a large distance with small beam of divergence. In the military applications, they have many applications. Here, the weapon guidance, mine detections, ADAS display, dazzles, high target lasers, target designations. The purpose of military, they can use it for the different things. Now, I hope you understand, student. Now we